Hey everybody, okay, so Go Component Lab. We're doing an RPC object manager today, kind of expanding on our QRPC system that we've been building. I actually put together, actually where is that dialog? Let's see, here, and then here. Okay, and then I can put this on the screen for you to see. Kind of been putting together something to kind of attempt to communicate where I'm going with some of this stuff, although it's not finished. But if you remember, we were working on the sidecar supervisor, and then we were doing this RPC daemon thing, which will probably be renamed to QBus, and then started working on some stuff around duplex, which we're kind of recreating with QRPC, and then we've started doing some QMux stuff and how all that's related and where it'll build up to, and etc. So hopefully this will provide a sort of like roadmap as to what we're doing and where we're going, and why we're doing these things maybe. But if not, you can always ask me if you're watching on YouTube. I'm watching chat in Twitch, so if you're on Twitch, say hi. If you're watching this on YouTube afterwards, then leave a comment if anything's confusing or whatever. Yep, Fubins, you missed it. You can watch it though; it's up there if you wanna do some art. There were some things I mentioned that would be helpful for you to do this week. And again, let's see, we have our, everything that we're doing is in the program prototypes repository, and what else? Let me close out Unity. And hopefully I do a recap. Again, actually, yeah, hopefully I don't forget to do that. All right, so let's see. This is not the code that we want to look at. Still not super satisfied with VS Code, but I'm still using it, so there's that. Earlier today I was working on porting QMux to TypeScript, and we didn't get very far, but at least I have a better idea of how to approach it and where to go with it. Also, this was not on the stream, but over the weekend I did implement QMux, and we did implement a QMux transport for our QRPC, so let's see. I'm just gonna clean some stuff up here. Don't really care about that anymore. This gRPC demo is sort of not relevant anymore. QMux, this quick demo isn't really important. We have QRPCs, pretty good. RPC daemon, or if you remember, we made this out of the supervisor. What else did we? Oh, and we did it with duplex. So at some point we'll bring RPC back in here. We have to build the aggregator for that though, which I think we're doing later this week. So there's also definitely follow me on Twitch and turn on notifications to get stream notifications, but also you can just remind me on either the series or individual things. Yeah, it looks like on Thursday we'll be doing a hub with QRPC. So I'm actually going to rename this to QBus. A bunch of Q stuff. What does the Q stand for? I don't know. I actually started with quick, but it's a nice prefix to start stuff with. It's a less common prefix. All right, so QRPC. We have our RPC system, and we actually started working on a thing to kind of export functions. What I wanted to do was actually have it reflect in the style of a lot of other RPC systems and dynamic languages, automatically assign the object parameters. You have some kind of object representing your arguments and actually pass them as the arguments by their name. But unfortunately, Go doesn't have any kind of way to reflect on the names of parameters. So at least in Go, we're gonna kind of avoid doing that kind of thing for now. We might get to a point where you can have some metadata where it kind of provides that for you. But the thing that we are trying to do today is get it so that you can have an object on one end that you can have a reference to on the other side. And so it's not like a stateless service. Most RPC people realize that it's better to do stateless services. Instead of and this is kind of a very kind of anti-stateless thing. You're saying, well, actually, here's an object, and it's very unique. It might be unique to this session, to this particular client, and they have access to it. So we need to have a manager that both serves up the methods on that object at a particular unique address, as well as expose those methods over RPC. So I thought we would actually start with doing a CEO AJ. Welcome. So I thought we'd start with doing something that would actually let you take an object and it would expose its public methods, assuming that those public methods. Okay, and that's where we come back to this idea of the signature of the function, because we're probably only going to be able to export things that take more or less a single argument. So let's see. I mean, normally it would be some params, as opposed to having like a list of like a string and an integer and all this stuff. And so one thing that the dbus library in Go does is it actually looks to make sure that you're using that you return a dbus error. I don't think we need to have that level of opting in, and maybe I'm overthinking it, and we can just kind of do this and assume that we're only going to have single argument methods and then kind of go from there, because there's kind of a lot of work ahead of us on this. Let's see, did I write? No, there's no to-dos on this. So kind of the first thing is create a handler that serves up methods on an object. Doesn't have to be a struct. In Go, any type can have methods. So it actually might start looking like this, and actually, it might be a good exercise to do this function one, and then we can reuse that when we get to the methods, because it's a little different. The reflection code is a little different, but pretty much the same. So All right, so before that, we'll create a handler that serves a single function with a single argument. The return values is also a thing. We'll kind of single argument and single return, not including an error. So you can return either an error or nothing, or a value and error, but not multiple values and an error for now. And then from that, it should be a little bit easier to create our handler that serves up methods. Once we have that handler where we can create a handler for every and then we can get to the object manager. So we'll see if we can actually get to the object manager. The difference between creating just a handler is we would let's see, export func. We'd have something like just export, maybe export methods. We'll see how this goes. I didn't want to do export object, but so that gives us a handler, and then that handler we can actually mount on our API somewhere. How do we do that? Our API says handle path, so it's like very similar to HTTP for now. Without like muxing, we just have specific paths. The object manager is different in that it will basically create the handlers for us. We say, here's an object, and it's going to keep a reference to it, so it actually sticks around. You know, we have stuff to worry about, like, is this object specific to a particular session, all this stuff. So we'll start getting to those questions there, but we'll start here. And so we're not going to do positional argument stuff. We need to make sure it's valid. So our rules make sure it has a single argument and a single return, not including an error return. And so in this way, we probably don't want to just return a handler. We probably want to return a handler error. And we probably want to do that even up here. We're not going to do that. Let's see, so we're going to decode this object. All right, so we're going to be hitting up some Go documentation quite a bit here. If we reflect on let's see, a value. I think we want both. why it's not auto-completing. So our type is actually what's going to give us I guess first we want to check to see its kind. Can we do that from, well, we'll see. Func. We're doing some shitty errors, but it takes only a function. We'll come back here. On the user interfacing, it's hard to say. Export func is something that you would say, you know, here's a function that I want to expose over RPC, and you get a handler. So this is part of that API. So in a way we are. Yeah, this is closer to the developer-facing stuff. Yeah, that transport stuff we were doing before, developers never going to touch that. So this is more developer-facing stuff, closer to developer-facing stuff. Or is developer-facing. Really depends on your levels of abstraction if you're going to do any kind of generation or stuff on top of this. But so now we're going to look at arguments. Let's see, number of in. Yeah. The developer probably, what this would look like is, you know, you have an API and you can, what was it called? Handle, that's what it was. So once you have an API object, you know, my func, and you would say export func, you know, whatever your function is, and that would wrap it up in a handler. And the reason for this is because the handler that we have has this serve RPC call, and so you know, it doesn't do anything magical to sort of do any reflection or anything like that. That's where we're getting to. So initially we're going to get this to export a function. That reflection code will be useful when exporting methods of an object, and so then we'll do another handler that, I don't know if we want to call it export methods or just export, you know, a value, in which case it will export the public methods. But it's not like a full object. You can't mess with properties or anything. That's going to come in a later kind of layer of abstraction. So the developer has the choice to kind of use any of these depending on the complexity of their system. But I'm doing it also just so that we're kind of building up the building blocks as we go. But the goal is nearly any arbitrary object we can expose over RPC. What does the handler represent? In this case, the handler is just something that will serve up an RPC request. You can think of it a lot like HTTP, and an HTTP handler will serve up an HTTP request. The handler is kind of just a low-level API. Let's see, where do we define that? So handler is just the interface that says serve RPC. We get a responder and we get a call, which is, you know, intentionally formatted very similar to HTTP. So the responder actually lets us return a value, and all it's doing is serializing that using our, we'll abstract out some kind of codec later, but right now we're sort of hard coded to message pack. So all it does is serialize that with message pack, and then sends that over a over this call's virtual connection, which is multiplexed over the persistent connection. So handler is not really specific to any transport protocol. Yeah, so there's definitely, I mean, we'll kind of have to see it in action. You might want to watch a video or speed through a video, or at the end is the last 5 minutes where we kind of came up with this API, and so that might help. But this code is also in the repo, and you can just follow along that way. If you go to GitHub Program prototypes, everything's up there. There's not a lot of code here, so you can follow along that way. If you'll use it. I mean, yeah, I mean, you might look at gRPC. I think that satisfies most people's requirements. I think the big differentiator here is, I mean, ultimately that we can kind of use it with some other transports, which lets you a little bit more directly use it from stuff like the browser. But I think the big differentiator here is that it supports callbacks and is bidirectional in terms of who can provide methods. And so this is kind of going the direction of dbus as opposed to kind of classic stateless RPC like gRPC. Num in. Again, these are like short-term error messages. This is something that actually might be worth writing some tests for, because then we can kind of do some to see how well this stuff works. Type functions, output parameter. We actually need to do this so that we can get the object that we're going to decode into. Nope. Do an in. Now, I'm trying to remember how we can create a new instance of a reflected type. some version of this definitely did this. Go look at some old duplex. Let's see, what is this? Either one of these will probably do it. Oh man, this is some old stuff. Let's see. This is kind of exactly what we were looking for. Let's see, what would happen if we just did a pointer? Let's see here. No, we're not going to return. This is a value. Yeah, I mean, there's been a lot of RPC systems, but that do distributed objects. Most of them get made fun of, like Corba and DCOM and stuff. The one I was looking at recently as a reference was distributed Ruby. Because it's interesting that it actually is part of the Ruby standard library. And works pretty well. So I was kind of looking at it, and so they were kind of talking about, let's see, Marshall, remote methods. Somewhere in here it talks about how it manages the objects. Rather Marshall is in here. This ID object, right? So we kind of do something similar. They have kind of a pluggable system where it uses an object space ID, and then the reference to the object only remains for the lifetime of the object's process and lifetime of the object within the process. So there are different versions of that where you can do where it maintains a reference to it for a particular time. Let's see. Yeah, but I mean they're also talking about how do they maintain that reference and how do they manage that reference, right? Right. There's a difference between saying this object is going to be available, you know, in as long as you'd normally expect it to be in the Ruby process remotely, versus saying like this object is only going to be available over RPC for 10 minutes, right? There's also, you know, just kind of general garbage collection, right? If you have a process that's running forever and you have people that are connecting and creating objects and you're just sort of maintaining a reference to them indefinitely, you know, those pile up. So having some kind of garbage collection for your references, right? So maybe references only last as long as, you know, that connection, because it's an object that's only going to be specific to that particular session. So that gets into some of the like complex stuff, but we'll get there eventually. Yeah, yep. Right, which is, you know, probably a good practice. So similarly, like here, we'd probably want to do the same thing, and just have some way to understand what the intention of an object is, because sometimes an object is really only specific to that session. And so maybe you can say when they disconnect after a certain amount of time, then it's cleaned up. So being a little bit more aggressive than the default, I think is a good idea. But let's see, what's the next thing that we did. So read object. Let's see, frame, codec decode. Oh. I was kind of assuming that this was kind of expecting. Huh. Yeah, if our param value is a value, I kind of expected it to not be able to be used in the same way as. I mean, especially if you think, to kind of answer your question, it's sort of like, what options do you have? Like, how do you expose an API? If you're going to provide any kind of library, you know, that gives them some kind of actual local API that they can use, it then has to communicate to it remotely somehow. So there's a lot of different ways to do that, and the trendy thing to do is to use HTTP. Which, if you think about it, is just, you know, RPC with the methods of get, post, and put. You know, so the problem is, you know, more trendy among web programmers, which also makes it accessible, right? There's a lot of documentation. So part of it is like, you don't want to do necessarily something custom because people are like, well, what's that? That's weird. You also have the problem of like support. You know, is there a library in my language for that? And when you're dealing with an RPC system, that's a big deal. Yeah, but you know, also if your customers are JavaScript people, then it would be great to meet them where they are. So to me, RPC, regardless of whether you're doing like persistent objects, you know, I feel like in your case, maybe it's possible that you could do kind of a more traditional stateless RPC system using something like gRPC. But you know, if you're exposing an API, you're exposing some kind of RPC, whether it's called RPC or not. So that's kind of my opinion. So I still can't get over that this is a var input value. I wonder if various codecs will actually kind of take a reflect value and do the right thing. That could be the case. It might be what I determined here. Ultimately, though, we're going to be doing a call. So we got a param value. In theory, at this point, we'd be ready to do the call, which we'd actually do in here. So let's see, param values. This is at this point an empty value. Yeah, we'd probably want to do that in here. This is back when we supported streaming, so this was a lot more complicated. Our method. Output. Okay, a reflected method. Let's see, what did I do? A lot of this code was actually extracted from Go's built-in RPC. Go actually has built-in RPC that's pretty good. It doesn't support any fancy streaming or anything like that, but it does all this reflection stuff. So most of this code is just kind of a cleaned up version of that. Let's see, well, where is that defined? A reflected method. Oh, I see. Okay, so call, this is finally what we're trying to get to. So method is, so in this case, we're not dealing with a method. So this might not work, but I'm curious. Ah, I see. So that doesn't matter because ultimately I think what we use is the function, so. Nope. Yep. So call, it takes in values and gets values out. So, reflect value. Yep, this is all pretty more straightforward than I even remember. Call. So this is reflected value. Oops. Let's see, what is this? The so this might actually end up being a lot simpler than I thought, because Go's reflection stuff is pretty great. Let's see, so basically we want to iterate over the values, check to see if any of them are an error. Let's see, what would be the best way to do that? Yeah, it's not part of kind. I didn't think so. But we can check, once we know that it's an error, we can check as nil. I guess we can, I mean, we could just compare it to the type of an empty error, but I'm gonna Google it real quick to see if there's anything. Yeah, that's what I thought. Create an empty error and do type of and then compare. We could even do that up here, just so we have it. Now at this point we should, in theory it won't have more than 2 return values, but we're just gonna iterate over them anyway. Let's see. It's a value, so it should be able to say implements, but oh, I think that's the type of it, so that maybe we can't do that. Maybe we could compare it. This is a weird example. Use the type's name. In theory, let's see, type of, do we want that? We could actually check this real quick in our Go playground. What would we have to do? Type of my error, which is a pointer, so we do this and compare it to error interface. False. Okay. So that's not exactly what I want. Type of my error element implements error interface. That seems weird. Why is this a pointer? Oh. I actually don't know exactly what it was doing there. Type of. Okay, well. I guess it makes sense. Elem would return if it's a pointer what it's pointing to, but I guess this makes sense. Oh, except we already have, so we'd want v type. Look for return values. Now, if I recall, right, so we actually only want to do something if it's an error and it's not nil. Right, in that case, we're going to do our return this value, whatever it is, but we have to unreflect it, basically. Which, let's see, how would we do that for an error? Yeah, we can get the empty interface and then type assert it, which is probably what we have to do. And we know it's an error, so we know that we can, so. So I might want to change this to say so that we can do else. And again, we're assuming up to 2 return values, 1 being an error. Though I assume if we have if we're not returning anything, we can just return this isn't, well, this won't work because we actually, if we get a return value that's not an error first, and then we get an error, we want to return the error, not the value. And so let's see. This would be see, but I don't want to overwrite it. No, I do want to overwrite it if I find it's this where I don't want it to be overwritten. So and this is kind of silly. I guess we don't need to do this because we will return early. Right. So it goes to the returns. If any of them implement the interface for an error and it's not nil, then we return the value for that error. As an error, we return. Otherwise, we just set return value to v. Again, assuming 2 return values, and we return that. So this might be different if we were to support multiple return values or whatever, but man, I think that's it too. All right, let's look at this real quick. It's a little bit more consistency. Okay, hold up. Yeah, so we set it, but we haven't actually gotten the value yet. So that actually, this happens first because this object is basically what we want to pull it into. So I don't know, we'll see if we can decode into a reflected value. We'll find out. All right, so we'll come back to that. Let's go to our demo. Let's run this demo as it is. This, by the way, is running over our QMux over TCP. So let's see here. Let's do kind of what we're starting. Export func simple echo. Takes a string, returns a string, logs that it was called. All right, let's then have the client do that. I'm actually going to have this stop doing. Oh, actually, yeah, no. Client. All right, what was this? Simple echo. Now we need to set up a response, which we know will be a string. Could work. Multiple value, single value. That's right, we did. And, you know, I don't know how I feel about this because it's a little inconvenient that we have to do this. All right, what do we got? Decode. Non-settable reflect exactly what I was worried about. So I suspect that we could just grab the interface. That is what I think. And I'm surprised that the other code that I was looking at as a reference didn't do that, but potentially, no, we want to do this. Okay. Call using string as the type string. Okay. Right, so we're type string. So it seems like we have a pointer that we need to dereference through reflections. So let's see. See, it's interesting because our param value, param type is string, not a pointer. Oh, hold on. Param value. Oh, yeah. This is interesting. So this is creating a zero value string. And then we're getting an empty interface to it, which is then, and that's what's past decode. So there's some, I know I'm somehow getting a string. Do I want to say element, interface, param value? I don't think so. This is the confusing stuff with Reflect, is dealing with pointers, and honestly, I just kind of guess. Yep. See, param type is definitely not a string. I'm wondering too if this was easier if this was a struct or something, but let's see, call. Optional. How can we dereference as interface? I'm thinking also we could just decode it into an empty interface object pointer and then try and assign it. Not append. So this is what I was thinking. This feels a little bit more clear too. Right. Is set. Okay. It panics if can set returns false. So we probably want to check. Well, can set, assignable, whatever. But we'll try this and then see what that. Using unaddressable value. We are just passing a string, right? Does it mean we need a reference to it? Or let's see, I don't know. Yeah, I mean that's kind of what I was thinking. But I mean, if I was to do this, that would kind of do it, right? Oh, did I not save? Unsafe pointer. I don't want to do that. I thought this would have made sense. It's like set to a value. You know, this is a string, that's a string. I mean, I'm pretty sure this is a string. It seems like it's making it a string. A pointer to a string. Why? So the first one is a type. Kind 18. I don't know what kind that is. Do we have an easy way to get the string for kind? Oh, we do. We can say string. Let's first do this. Param type kind string. Right. And yet, param value. Oh, it must be because of new, right? I don't know if there's another way to a pointer. Well, maybe it's as simple as just grabbing the element. Not of a value, but a type. Element returns a value that the interface V contains or that the pointer V points to. So I can't think of a case where we don't want a pointer, so it worked. unfortunately, our demo is waiting for this done, which is only called when we hit this echo server, which we're not doing anymore. So I'll just hide that. So, we could also do types, like if we were to change this to something that maybe takes an echo message and returns, we'll do string. We could do like strings to upper message dot message. Oh, there we go. Okay, that's because that's okay, yep. Need to check that it's assignable because this is the case where we're still trying to call it, passing it a string. So, I don't remember if it's assignable. Let's see, reports whether value can be changed. We should probably do that, and then type assignable. I guess we'd have to look up type. The type has whether it's assignable. Nope. Thought for sure there was something called assignable that you could call. Assignable to. Okay. Or, and that was assignable to, takes a type. So we're going to do a type of the object assignable to. Then we have our Mike Doplay, welcome back. Good type. No. That's not the function. We need the param type. So this would be a. Basically, we would return an error. Very cryptic, technical thing. So now we should see that error. Parameter is not assignable, and that's an error coming from our demo. We're panicking here. But if we fix this and we actually create a echo message, with a new message, hello world. Ooh. So I guess what's helpful here is, what would be helpful here to see what's like a name? Is this a step forward? I can't tell. Parameter is not signable to echo message. So that's very odd, right? Because we're actually sending a thing. So let's see if we can find out what type of object it is. And this is not going to be anything helpful because it doesn't really know what it is, I don't think. Yeah, it's like, what is this? Though, let's kind of see what the value is. Let's see. This is the problem. Decode is using the type that it's passed in to figure out what to decode it as. Like this doesn't do the same thing that this does. So we're gonna have to pass something in here. I guess though, now that we've done this, we can actually do param value interface. Which maybe we don't want the pointer to it, but maybe we do. This stuff becomes kind of not relevant. Can't take the address of it. Okay, how about just taking it, because that should be thought of like a non-settable main echo message. I suppose what we want is this, I think. No? Right? Can't take the address of it. Why is this? That's so weird. Like, what if we had an object? We're like, give us the interface of this param value. And then we're like, hey, give us the address of this object. Again, an unaddressable value. Param value elements. Then what if we go back to the pointer, and that's what we pass. Oh, it doesn't have a pointer? Right. Because we made it not a pointer. Okay, so wait. What if we leave this as a pointer for here? And we do this. Like, does this at least get us past the decode? Right, and then we can do this. Yeah. Whew. I think we'd have to actually check to see whether it was expecting a pointer or not, though. Because, like, if it was, for example, if we were to just change this and say, so if it wants a pointer, params is this. Otherwise, so it should work either way now, right? If it wants a pointer or if it wants value. And this should work if we go back to a string. It might complain that it's not assignable. Let's see what happens when it does this. Ooh. I think because we're giving it a type to decode as, and then it's not that type. And so that is this error here. And so this is the error where we would have to say, you know, that the arguments weren't what was expected. Or any other error. But if we wanted the place where the error would, for unexpected argument types to happen, that's where it would be now that we're not doing all of this. So let's change it to the right. I kind of hate having all of this helper shit in the way. Like scrolling to the bottom. Okay. And we'll replace this. Go back to hello. We should get back. Hello. So that's it. We did handler func, or export func. We should be able to kind of expand on this and do export some value. So the difference is if we were to mount this handler on, say, foo, then each of the methods would then be a sub path, I think. Pretty sure. Pretty sure this is kind of how I want this to work. Yes. So we actually we can reflect on the type and get all the public methods, and then for each of those more or less do the same thing here. We might be able to reuse this or refactor this into something that we can reuse. I'm sorry, because this reflection stuff is you know, a very tricky thing. So there's a lot of like debugging. It's not as quick as my usual like all comes together. So we start the same way. Luckily, we have a quick way to these. So we just iterate over a method, and then we get a method. Let's see here. Which gives us a name. And then the func value, which gets us in a very similar place to where we were. Index for type method. So we start here. Thinking, can we actually use this exact same thing? I think we can if we get a handler back, and then we create kind of a muxing thing that will look at the call and see what the method that it's supposed to be using. Okay, so let's make a map of handlers. Let's see, this would also potentially return an error. This is a method. I guess we can't iterate over anything to get this, so we'll just have to do a for loop. Num method, sorry. Method. Our method. Right, so this is where we're calling export func based on the func, which I'm not sure exactly how it'll work with. This might need to become compatible with a receiver object, because I'm not sure how this is going to work with receivers. If you were to call this func, maybe it'll say. Oops. If it's not a func. Slice parameter itself coming. Doesn't say anything about what happens if this value is a method. Just arbitrary keywords. How to get explicit receiver of a method? Use a single method interface. Takes a function and taps it to the interface. What the fuck? No, I don't think this is... Oh, I see, I see. So you're saying, right. But it should work. Okay, I'm guessing it'll just kind of work, right? Alright, so I don't have to do anything special. Okay. Otherwise, let's say method handlers, our method name equals handler. Right, so we set up a map of all the exported methods on this value. And so now we just need to create a handler func that will call the right one based on the calls method. So in theory, we could do this. We don't populate it, but now might be a good time to populate it. So, because then we could easily say method handlers. Oops. Now we would do something like this somewhere up here. Handler does not exist for this destination. Sure, we'll say that. Otherwise, yeah, we basically just call that handler passing it RNC, just like we would a HTTP handler thing. What's the problem here? What? Oh. What? Oh, that's true. This is gonna have that problem too, huh? That's... Oh, it doesn't, because this is gonna return an error. Wait, this has that same property though, so what's the problem here? Out of arguments to return. I don't know what you're talking about. Wait. Oh. Yeah, I'm a little... Yeah, that's all. That's all. Need to return a nil error. What's this problem? Response undefined, that's true. R. What's this? What? What? Cannot call non-function handler. That's right, because it is server RPC. Let's try this and see what we get. It'd be cool if this kind of magically worked and doesn't need to worry about receivers. All right, so we'll do kind of a stateless thing first, and then we'll do something more complicated. So, demo service is a struct. And it still has the same constraints as before, where we can only take one argument. So we do upper and maybe upper and echo. We'll see. Oops. Let's do 3 different ones. Let's do upper, echo, and something returns an error. How about just error? Or it just returns an error. I like this. Okay, so we're gonna do another. I guess we want to. I guess we can reuse these. And I will create a new instance of our demo service. I wonder if that would even return an error. I guess it's possible. API handle, we'll call it demo. So now we'd have to call demo slash in a method. this. Takes only a function. That's funny. Demo 60. Takes only a function. Export func. Oh, because we didn't only supports one argument. So it sounds like it's actually passing the receiver as the first argument. Right, because there's nothing that we'd be exporting that takes more than one argument, so. Let's see what to do. I mean, the obvious thing, I guess, it's not obvious, but the quickest thing is to create a sort of private shared version of this that says whether it's a method. And then this one would say true. And shit. I suspect if we do call, we will have to pass it. We'll see. I'm just gonna cheese this and duplicate. I'm guessing that's why we're getting a different thing here. So handler does not exist for this destination. Okay, we didn't actually specify a method, so we should actually implement that. Let's see, when we call, let's see, when we get a... we want to do a split. We have 20 minutes. I think we can... Well, we might be able to get to a really basic object manager. I was hoping for like a reverse split, but in theory... I guess we can actually put this on call itself. Because it has its destination. right? Serve call. I can actually kind of do this anywhere. That's true. That is true. Okay, what's this problem? Wait, what? Oh. Yeah, no, I do just want the last one. I'm thinking byte streams because of the transport stuff I was doing earlier. Okay. Still seems to be a problem. Let's kind of debug this a little bit. Demo. Let's do a couple of things. Let's see our method. I guess let's see what's in method handlers. That's true. So it's actually not getting past our now I'm going to say method handler does not exist, so I can differentiate between those two errors. Right. So it's because we're just doing a lookup here. We're not doing, you know, iterating over them and doing like starts with. I guess we could do an initial lookup and then we can iterate over them and then see if any of them, if the requested destination starts with that key. So we can kind of do the fast lookup, and then in theory it's slower. I don't know if it is, but if it doesn't exist. This is the key. I'll just do key value. Has prefixes. What I want. Key. Then we can set handler to that. And break. Unlock. And then we can say if handler is still nil, all right, what now? Okay, those look all right. Decoding map length. The problem is it doesn't seem to be happy with our again here. Okay. Here's where we went wrong. If method, then we want the second one, so. Problem will probably surface that we need the actual receiver to be passed as well, but that shouldn't be that big of a problem. Call with too few input arguments, exactly. So okay, let's do this. We will actually append params, param value, because we can do this to an empty value, but then we can also start it. So we can say if, right? If it's a method, then params, so append params. And what we want here is the value. Oh shit, we don't have the receiver. So I guess we could do a receiver here. He. So if receiver is not nil. We actually want the value of receiver. Oh, so close. All right, what now? Is it actually going to return a different value here? 248. Oh, that's funny. I thought this would have been oh, but we're not passing receiver here. We're not using this properly. Receiver SV. Okay, it still doesn't like that. It's basically saying that there's no, I guess we're not actually saying that. I guess we should be more explicit and actually be like, if it's not 1 here and if it's not 2 here. This will make things a little more clear. Okay, so I don't know where I got the idea that it was actually passing 2 in for index out of range. So its num is, it only has 1. How do we pass the receiver? Maybe we don't care. This whole time I was thinking we're passing the receiver in. Yeah, I know, we... Alright, how many do you have? I guess that would be integer. No? How do we get up? I don't remember printf. Thank you. Thanks, cockies. Cockies, yeah. I appreciate that. Thank you. Also, welcome. I haven't seen you. All right. Okay. So, which one is actually taking 2? Let's see. Error. Oh, Cockies, thank you for following. Are you a Go programmer? I mean, are you a Go programmer? I was thinking, if you said it, but you don't have to be a Go programmer to know how printf works. Anyway, are you? Let's see, our method name. Echo. Yeah, I do love it. I mean, I try not to be a zealot to people about it, but it's very much aligned with my values. All right, let's look at echo again. Echo only takes one thing, so I'm confused because it's like, which? Oh, you know, oh no, I know what's going on. Check it. This should have been sending nil. We're getting errors before for the wrong thing. All right, so I was right about, I think I'm right about this receiver business. But I was misled because we were registering some other functions as well. Even though this is ridiculous, I will copy it. And again, well, let's see if we get this far. It's happening because of all this, so it's getting further, so we're on track again. Oh, it's 7. God, we're so close. I want to keep going. Python is where I came from as well. All right, let's change this up a little and have it call a method based on the R. Well, we'll just flag parse so we can do flag args because that's a little bit easier. What's interesting? Oh, Python and C++. I think that's pretty common. Echo. Oh, because you're, well, I mean, yeah. I mean, I think though, I don't know if I've been I think I've been a Go programmer longer than anything else. I mean, I'd used Python for years, but sort of like there's always a dominant language. Yeah, especially I came from using, I don't know if you're familiar with Python. I mean, it started with Python Twisted, and then finally someone convinced me to check out Eventlet, and then gevent, which is like a fork of Eventlet. And it's basically Go primitives in Python, but hacked in. So finding Go, it's like, you mean I get all of those primitives natively, and it's faster, and it's type safe, like, and you know, all the other benefits. So, all right, so echo is working. Upper works, and then one where we return an error. Did we just call it error? Error. So we got an error where, yeah, hello. So we have registered this object. That's cool. Let's see if we can, let's make sure that the receiver is being passed in. We'll do something like prefix. This is stupid, but oh my god, interfaces. I mean, interfaces have, you know, been around, right, in object-oriented languages, but I used things that would implement interfaces in Python. I've not seen interfaces implemented like Go, and I think it is one of the best implementations of interfaces and gets you thinking in terms of using interfaces culturally within the community too as well, programming the interfaces and designing APIs around interfaces, unlike any other I've seen. So alright, we get a prefix now on all of these. Alright, so we are getting the receiver, so technically that is an object exposed over RPC. We did not get to the manager. The manager is kind of the interesting stuff where we can say register this and it'll maintain the reference and clean it up and stuff like that. But this is the building block to get there. And I think it's great that we did it on top of on top of, oh god, where is it? On top of export func. So we can export functions and we can export a value in all its methods. All right. All right, so that's pretty good. I'm gonna do a quick recap and then close up here. But it's fun hanging out with you guys. Thank you for saying hi and participating. I hope you all follow me so that you can, as well as if nothing else, remind me on these, because I stream other stuff as well. And but I kind of put my schedule up every week. So hopefully you guys will join me on Thursday at the same time. All right, let me think how I'm going to recap this nonsense. Let's look at our demo. Okay, I know how we're gonna recap this. Thank you. All right, so we're gonna recap what we did today. Our goal was to build an RPC object manager in Golang. We've been working with our QRPC library, and so far we basically have a system where you can register handlers, which will handle function execution or the remote procedure calls, using this API that's very similar to kind of in spirit the HTTP library, which gives us a lot of possibilities in terms of designing middleware and wrappers and stuff like this. But ultimately what we want, so here we're creating an echo client method, but we have to manually decode our arguments and then return them with this call. with the responder. But we'd like to write functions a little bit more regularly, right? And so what our first goal was, I guess I should start with the fact that we didn't really get to the object manager, but we did several steps getting to the object manager. We have this new method, export func, that returns a handler given a function. So in our example, we have this simple echo, and it takes a string and returns a string and an error, prints out that it was called, and returns to upper. I guess I was changing things a bit, but if we were to just change it back, then it's an echo. And the idea is that we could export this by saying export func simple echo. It does some processing on it, so it does return error. Otherwise, we could just do this inline with handle. But we get a handler, and then we can say handle simple echo handler. And so in that way, it's basically generating this kind of, if you think about it, on the fly for this particular function, and then calling that function. So that is export func. And then we actually ended up being able to use most of this code to be able to export a whole object. And by object, I do mean a value with methods, because that's kind of how Go works. And so here we have an example of a demo service struct with a couple of methods on it, upper, echo, error. Upper obviously does upper, echo echoes it, and error actually returns an error with the message that you passed. And so not only does it export all of these functions sort of in one go, and so now they're all available at whatever path / upper / echo / error, you actually get whatever these get access to the receiver as well, because we created an instance here called demo service that passed in a prefix. You can kind of see this here where you can call demo echo, demo error. Our clients just, and so this is intentional. We're getting back. It returned an error, so, and we're panicking on errors. So, and so this is a great start. The object manager, the way that that's different is actually uses this to actually manage these references to these objects. So it's more of a like create an object manager, and that in itself will provide a handler that you can mount at like /objects, and then you register objects with that manager. And then it'll generate a UUID and create, objects / some ID, whatever, and all the methods on that object, and then return that path to you, or something like that. That's kind of the general idea. And the reason why we have the object manager is to basically manage the life cycle of that object, because once it's registered, you don't want every session to be generating tons of these ephemeral objects and then having them live in memory for the rest of the life of that daemon's process's lifetime. So we need some way to kind of clean them up, and there's different approaches to that. But that's what the object manager can be responsible for, among some other things. So we're getting there. We didn't do it this time, but I think in possibly an unscheduled one, but otherwise maybe next week we'll get to the object manager. But that's great. We also started, even though this isn't finished, this is kind of the roadmap of kind of where I'm going, why I'm building the stuff, which we'll kind of be explaining more as we go. But definitely building up a bunch of components to build up to things to build other things. So we'll see. All right, everybody. Thanks for hanging out. Thanks for following and participating. I'll talk to you guys Thursday or tomorrow, maybe tomorrow morning. See you next time. Bye.